Imagine an invisible monster in space, one so powerful it can swallow entire stars, stretch your body thinner than a strand of hair, and even slow time to almost a complete stop. These aren't scenes from a science fiction movie, they're real, and they're happening in our universe right now. Today we're diving into the most terrifying truths about black holes, facts that are stranger than fiction and far more dangerous.
You might never look at the night sky the same way again. A black hole is what happens when gravity wins. It's a region in space where matter has collapsed in on itself, so dense, and with a gravitational pull so strong, that not even light can escape. Black holes are born from death. When a massive star runs out of fuel, it explodes in a supernova, and what's left behind is a core so heavy it crushes itself into oblivion, forming a black hole. But here's where it gets truly disturbing: everything that falls into a black hole is gone. Not crushed, not broken, erased. And we can't see them directly. We know they exist only because of what disappears around them: stars ripped apart, gas spiraling in at near light speed, space itself warped beyond recognition. They're not just holes in space. They're prison cells for reality. Of all the ways the universe could end you, spaghettification might be the most disturbing, and yes, that's a real scientific term. This gruesome process happens when something crosses the event horizon of a black hole, the point of no return. Past that invisible boundary, gravity becomes a monster. It doesn't just pull, it rips. You see, black holes don't pull evenly. Their gravity increases so rapidly as you get closer to the center, the singularity, that if you fell in feet first, your feet would be pulled with far more force than your head. To your body, that means one horrifying thing: it starts to stretch. But this isn't like being on a medieval rack. It's infinitely worse. First, your body would begin to elongate, your bones, muscles, and skin pulled downward. Your internal organs would start to rupture. Blood vessels tear. Cells are sheared apart. At a certain point, even the atoms that make you would be wrenched apart, leaving behind a long, thin stream of atomic dust spiraling helplessly toward the singularity. Horrifyingly, depending on the size of the black hole, you might still be alive and conscious, for a brief, agonizing moment, as your nervous system is stretched past comprehension. Your brain, still processing sensory input, distorted into a linear string of pain. And don't think this is some rare fate reserved for unlucky astronauts. Black holes aren't picky. Anything that crosses their threshold meets this end: planets, stars, space dust, even light itself. Spaghettification is not just a grotesque word. It's the fate that awaits anything foolish enough, or unlucky enough, to get too close to one of the universe's most terrifying predators. Black holes don't just warp space, they warp time itself. According to Einstein's theory of general relativity, the closer you get to a massive object, the slower time moves for you, compared to someone farther away. And black holes? They're the most extreme example of this in the entire universe. If you hovered near the edge of a black hole, just outside the event horizon, time for you would slow to a crawl. Minutes for you could be years, centuries, or even millennia for everyone else. You could spend 1 hour near a black hole, and return to find that everyone you knew is gone. Civilizations might have risen and fallen. Earth itself could be unrecognizable. This isn't science fiction. It's been proven with atomic clocks near Earth's gravity. The difference is tiny here, but near a black hole, it becomes reality-shattering. And if you fell in, time wouldn't just slow down. From your perspective, the outside universe would speed up, stars racing across the sky, galaxies spinning fast forward, until you witness the end of the universe itself. In a very real sense, black holes are time machines, but only one way. You can move into the future, but never come back. One of the most unsettling truths about black holes is that they don't stop. They can grow endlessly, 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 with no known upper limit. A black hole starts small, perhaps the size of a city, but with more mass than several suns. Then it begins to feed. It consumes everything that crosses its path: gas, dust, planets, stars. It doesn't digest or destroy, it simply absorbs. Once something crosses the event horizon, it's added to the black hole's mass. Forever. There is no known force in the universe that can say enough to a black hole. Ringed planet case study number 1, Sagittarius A*, the one closest to us. At the center of our Milky Way galaxy is a black hole called Sagittarius A*. It's relatively quiet now, but don't let that fool you. It has a mass of about 4 million suns and controls the motion of entire star systems in our galaxy's core. If it ever started feeding aggressively, like others in the universe do, it could light up the sky with radiation and magnetic storms so intense, they could fry satellites or even disrupt life on Earth. Milky Way case study number 2, TON 618, the monster. Then there's TON 618, a black hole so massive it breaks our understanding of what's possible. It has the mass of approximately 66 billion suns. That's right, billion with a B. It's so far away, the light we see from it today began its journey nearly 10 billion years ago. This isn't just a black hole. It's a galactic god, an ancient monster feeding in the darkness of the early universe. Scientists can't explain how something could grow that fast, that early. By all current models, TON 618 should not exist. Flying saucer case study number 3, S50014+81, the overachiever. Even more puzzling is S50014+81, with a mass of about 40 billion suns, and it's burning brighter than entire galaxies. It's devouring matter so rapidly, it's creating a quasar, a cosmic beacon powered by a black hole's feeding frenzy. Think about that. A single object, the size of a solar system, burning brighter than 100,000 galaxies combined, powered entirely by gravity. So, what's the limit? There is no theoretical ceiling. Given enough time and enough matter, a black hole could grow to consume an entire galactic cluster. And when galaxies merge, as they often do, their central black holes do too. That's how they grow, through violence. Cosmic cannibalism on an unimaginable scale. And here's the scariest part, we don't fully understand what's driving their growth. Some grew faster than they should have, too early in the universe's history. That raises deep, unsettling questions. Did we miss something about the nature of gravity? Or, could something be helping them? Black holes don't just sit alone, lurking quietly in the depths of space. Sometimes, they collide, two cosmic titans crashing together with unimaginable force. When two black holes spiral toward each other, they don't just combine their mass. They create one of the most violent and mysterious events in the universe, a collision that sends ripples through the very fabric of space and time. These ripples are called gravitational waves. They're distortions in space-time itself, waves that travel at the speed of light, stretching and squeezing everything in their path. Imagine throwing a stone into a pond and watching the ripples spread. But instead of water, these ripples move through the invisible fabric that holds our universe together. In 2015, scientists made history when they directly detected gravitational waves for the first time, confirming a prediction made by Einstein a century earlier. The source? A pair of black holes merging over 1 billion light-years away. The energy released in this event was staggering. During a fraction of a second, the merging black holes emitted more energy than all the stars in the observable universe combined. But the effects don't stop there. Black hole collisions can warp spacetime so severely that they can bend the path of light itself, creating bizarre visual distortions called gravitational lensing. Even stranger, these collisions can sometimes produce kicks, powerful recoils that send the newly formed black hole hurtling through space at thousands of kilometers per second, potentially ejecting it from its galaxy entirely. Black holes colliding don't just reshape the cosmos, they rewrite the rules of physics in their violent wake. Scientists are still decoding what these events mean for our understanding of gravity, quantum mechanics, and the fundamental nature of reality itself. For decades, black holes were thought to be eternal, cosmic vacuum cleaners that would keep swallowing matter forever, never losing mass, never dying. But in 1974, physicist Stephen Hawking made a shocking discovery that turned this idea on its head. Hawking showed that black holes aren't completely black. Instead, they emit tiny particles, what we now call Hawking radiation, caused by quantum effects near the event horizon. This radiation means black holes slowly lose energy over time. They evaporate. For small black holes, much smaller than the ones at galaxy centers, this evaporation can happen quickly, astronomically speaking. They can shrink, lose mass, and eventually disappear. But the final moments are the most terrifying. As a black hole loses mass, it gets hotter and emits more radiation. A runaway effect. In its last seconds, the black hole could explode in a massive burst of energy, releasing an intense flare of gamma rays and particles. Imagine a cosmic bomb detonating in the emptiness of space, a violent end to a terrifying object that once consumed everything around it. For the massive black holes we know, this evaporation takes far longer than the age of the universe, so they seem eternal. But for tiny, primordial black holes, if they exist, their final explosion might still be happening somewhere, right now, sending out signals we might one day detect. This phenomenon connects the worlds of gravity, quantum physics, and thermodynamics, hinting at a deeper, still hidden theory of everything. Black holes, it turns out, might not be forever after all. But their death can be as spectacular and frightening as their life. What if I told you that everything you know, the stars, the planets, even time itself, might exist inside a black hole? It sounds like science fiction, but some physicists have proposed that our entire universe could be the interior of a massive black hole. This idea comes from the strange mathematics of black holes and cosmology. The boundary of a black hole, the event horizon, acts like a cosmic membrane. Inside, the fabric of space and time behaves in ways we can barely imagine. In this model, the universe is expanding inside the black hole, much like our own universe is expanding outward since the Big Bang. The singularity, instead of being a destructive point, might be a bridge to another universe, or even the seed from which our own cosmos was born. If true, it means the universe itself could be trapped inside a black hole in a higher dimensional space, like a bubble inside a cosmic ocean. This raises mind-bending questions. Is there a parent universe outside? Could black holes be gateways to other universes? And what does that say about the nature of reality? While this remains speculative, it challenges everything we think we know about space, time, and our place in the cosmos. In the end, the scariest fact might be this: the universe itself could be one giant black hole, and we're living inside its mysterious, infinite depths. Black holes are more than just cosmic curiosities, they're gateways to some of the universe's darkest mysteries. They challenge our understanding of physics, time, and reality itself. They stretch the limits of human imagination and remind us how small and fragile we really are. From their monstrous appetites, to the warping of time, to the possibility that our entire universe might be inside one, black holes are the universe's most terrifying and fascinating enigmas. So next time you look up at the night sky, remember, out there, invisible and deadly, lie the black holes, the ultimate cosmic predators. And who knows, maybe one day, we'll uncover their deepest secrets. Until then, the darkness remains.